Hi, welcome to a new video about sine law and cosine law. This video will talk about the basics. What type of triangles use which law? How do we label the triangles to work with the formula? And how do we solve for both angles and sides for both cosine law and sine law? Why do we need sine law or cosine law? Well, that's easy. SOHCAHTOA is what we learned in grade 10, and with SOHCAHTOA, we need a right angle triangle so we can label our hypotenuse, our opposite, or adjacent, and use a sine, cosine, or tangent ratio. If you need more information about SOHCAHTOA, please see one of my previous videos. So if we're looking for an unknown side or angle in a triangle that's not a right triangle, we simply don't have the tools to do it. That's why we're going to use sine law or cosine law, depending on what information we're given and how we're able to label the triangle. All right, let's have a look at sine law. First of all, let's look at the triangle. Notice for the first time it's not a right angle triangle. We have an acute triangle in this case. Let's look at how we label triangles in sine law and also later on in cosine law. First of all, we use capital letters for our angles, and then we use corresponding lowercase letters on the sides that are opposite. So you can think back to SOHCAHTOA and think back how you label the opposite side, and it's the angle directly across from the side. Now, the thing I like about sine law is I like to use what I call a loop. And in a loop, we have an angle and a side. We have an angle and a side, and we have an angle and a side. The nice thing about each loop is each loop makes a formula. So let's go back and look at the top here. So if we look at the first loop, A, the sine of angle A and the side of A are related. So oftentimes in my class, I'll write the sine of angle A over little a. But guess what? It's a ratio. It doesn't matter. And then we can do the same for sine B, which is sine B over little b. And I ran out of room, but it's also equal to sine C over little c. When we're using sine law, we only need two ratios. We're going to have three things that we know and one unknown to solve for. So in this case, we can either solve for a missing side or a missing angle. All right, let's look at the basics for sine law. First of all, let's go through a few of the steps. Solve for all the angles, which means in this case we have angle C missing. So we have to figure out what's 42 and 75, and in this case it's 63 degrees. So we just pop in 63 degrees here. Draw the loops. One needs both an angle and a side, and the other needs one unknown. So in this case we need to solve for an unknown, so how about we solve for little b. And here's one loop, and here's two loops. Fill in the formula and use equivalent ratios to solve for the missing side. All right, notice how we're going to start to build the formula. I've filled in the 63 degrees, which is our missing angle, step one. I've drawn my two loops. One has an angle and a side, which is the C, and one has one unknown and an angle, which is B. Each loop makes part of the ratio, so that makes it easy. So the sine of 63 over 22 is the first loop, and the first part of the ratio is equal to the second loop, which is the sine of 75 over b. Now here's a mistake that a lot of people make when they solve the formula, is they do the cross multiplying wrong. So look for a third loop. The third loop is 22 times the sine of 75 degrees, and then you divide it by the missing piece, which is the sine of 63. Make sure when you put this in your calculator you do 22 times the sine of 75 degrees equals, divide it by the sine of 63, and you will get 23.849, and we can round up to 2 decimal places is fine, and the units check is centimeters, and the answer is 23.85 centimeters. Please make sure you're in degree mode, otherwise your answers will be incorrect. And that's as simple as it is for solving a missing side using sine law. All right, here's your chance to try sine law. Notice this one doesn't have any label, so that would be a great place to start. So you can label them in any order. We can label this one as A, B, and C, little a, little b, little c. So now what we want to do is check to see if all angles are solved. Oh, guess what? They're not. So let's go and solve for the missing angle first. All right. If you did the math correctly, which I think I did, you'll find the missing angle is 68 degrees. Now it's time for us to look at figuring out how to use the formula. So that's the next stage. What we need to do is draw our two loops. One that has everything in it. Well, A looks pretty good. It has a side and it has an angle, and C has the unknown and the value that we need. So now it's time to use each loop to set up a formula. So we'll use the sine of 63 degrees over 10. Remember, every loop is a formula, is equal to the sine of 49 degrees over the unknown. Remember, we need our third loop here. Our third loop helps us to build the formula. So that's the 2 we multiply. 10 times the sine of 49 degrees over the sine of 63 degrees. And if you do that correctly, you should get, with rounding, 8.47 centimeters. So there's your second example on how to find a missing side using Sine Law. All right, let's look at using Sine Law to find a missing angle. Notice this triangle doesn't have any labels, so let's start with the basics, and we'll call this A, and this would be little a, and call this B, and little b. All right. Notice our unknown now is an angle, so a little bit different than the last time. So first things first, let's find our loops. Here's a loop with A, which has our angle and our side, and here's our loop with B. It has a side, but this time a missing angle. So now we can write out our formula. Remember, every loop's a formula. So the sine of 63 degrees over 10 equals the sine of our unknown angle B over 8.47. So now what we're going to do is find which one has the unknown in it, which is in sine B, and we'll use these two to multiply and this to divide. So sine B is equal to 8.47 times the sine of 63 degrees all over 10. Now, notice that you have a sine here, so you're going to get a decimal answer. You'll have to do second function sine, and if you do that correctly, you'll find out that this angle is 49 degrees. So that's the only extra step you have to do in finding a missing angle, is use second function sine. All right, now it's your turn. You can see in this triangle we have our missing angle here, x degrees, and we have a known angle, 29 degrees, and two known side lengths. Again, always start with a quick label. You can call this A and little a, and B and little b. The name doesn't really matter. And now we draw our loops. So now there's the loop that we need that has both the angle and the side, and here's the loop that we have that has one of each. So now we build our formula based on each loop. So the first loop is sine of 29 degrees over the side length of 11 equals the sine of some unknown angle, x over 20. And now we solve for our unknown, again, sine x degrees equals, if we're looking for our third loop, which is here, 20 times the sine of 29 degrees all over 11. And don't forget, the very last step will be second function sine, and if you did that correctly, I got 61.8 degrees. So there you have it. There's Sine Law, finding a missing side, and finding a missing angle. So there's the quick 1-2 of Sine Law and Cosine Law. So for Sine Law, make sure you find two loops, one that has the angle and side, and one that has one of the unknowns. Please set up the ratios correctly. Sine A over little a equals sine B over B. Cross multiply to find the unknowns, and don't forget to do second function sine to find the missing angle. Cosine law, always look for the little hat on top of the triangle. It's a side angle side combo. And remember the second step, either square root to find the missing side or second function cosine to find the missing angle. And never forget, there is no such thing as tangent law. Thanks for listening.